Assalamualaikum and hi everyone. So in this video we will continue with the Gauss elimination method. What is Gauss elimination method? Okay, Gauss elimination method is a method that we use to find or to solve a system of linear equations by using augmented matrix, and we reduce to row echelon form by using ERO. Okay, so this method we call it as the Gauss elimination method with back substitution. Alright, so in REF of an augmented matrix, the variables that correspond to the pivot columns are called the leading variables, and the variables that correspond to the non-pivot columns are called free variables. Okay, let's look at here the example. We have here, it is a REF, okay, where you have two leading one, right? So this one, okay, it will be, the ladder is until the second row. Okay, so you have two leading one and another column you don't have any leading one. So the column with the leading one, we call it as the pivot columns. Okay, while the columns without leading one, we call it as non-pivot column. Okay, so the non-pivot columns are called free variables. So what does it mean? So in this example, we have an augmented matrix. When you want to solve a system of linear equations using Gauss elimination method, you will use later on the back substitution. Okay, so to use the back substitution, you have to know which one is your leading variables and which one is your free variables. For example, let's say in this question or in these examples, let's say the first column is represent for the variable x. Okay, let's say we use green. Okay, so for the first column is for x variable, second column is for y variable, and for the third column is for z variable. Okay, so from this example, your pivot columns will be the leading variables. So meaning here you will have your leading variables is the column which contains the leading one. So your leading variables here is your x and y. Okay, while for the free variables or for the non-pivot columns, it will be your free variable. Okay, so in this example, you will have a free variable which is your z variable, because the column for z does not consist any leading one. Okay, so these free variables and leading variables will be used to solve your back substitution. Okay, alright, recall what we have discussed before this. For a system of linear equations, there are three possible solutions. The first one, your system might have exactly one solution, or the system has infinitely many solutions, or a system has no solution. So if the system has exactly one solution or infinitely many solutions, we say that it is consistent. Okay, because it has solutions. But if the system does not have any solution, then we say that it is inconsistent. Okay, so next let's proceed with the steps. Basically, we have three steps to solve the system of linear equations by using Gauss elimination method. The first step is we will start with the augmented matrix. Okay, and then step 2 we will reduce until you will get in the form of REF, and lastly we will use back substitution to find the solution for your system. So we can say that we will start with an augmented matrix, that is A/B, and then we will reduce using ERO until you will get in the form of REF. Then you use back substitution. Okay, so we have two types of system of linear equations. Alright, system of linear equation. The first one is a homogeneous system, and the second one is non-homogeneous system. Non-homogeneous system. Okay, so in the next video, we will continue with the non-homogeneous system of linear equations, and we will see what type of solutions that you will get for the non-homogeneous system. Okay, now let's look at example. We have here solve the following system of linear equations using Gauss elimination method. We have here three equations with three variables x1, x2 and x3. The first equation we have 2x1 plus 4x2 plus 6x3 equals to 18, and then we have 4x1 plus 5x2 plus 6x3 equals to 24, and 3x1 plus x2 minus 2x3 equals to 4. So firstly, we will write in the form of augmented matrix. Okay, so step 1 is your augmented matrix. Okay, so the augmented matrix will be 2, 4, 6, and don't forget your constant 18, 4, 5, 6, and 24, and 3, 1, negative 2, and 4. Okay, next continue step 2, we will perform your ERO to reduce until we get in the form of REF. So step 2 is use ERO until you get in the form of REF. Okay, firstly we want to find your leading one. Okay, the first leading one here, we will write R1 is R1 divided by 2. So we have 1, 4 over 2 is 2, 6 over 2 is 3, 18 over 2 is 9. Okay, so make sure please perform your operations for the constant matrix here. Okay, alright, next is we will rewrite the rest. So 4, 5, 6, 24, 3, 1, negative 2, and 4. Okay, next, your next step will be make your entries below the leading one are zeros. So we will have here is R2 will be R2 minus 4 times with the leading one R1, and then R3 will be R3 minus 3 times the leading one is your R1. Okay, so now your matrix will be, so 4 minus 4 is 0. So if you write 4 minus, so 4 minus 4 times 1 is 0, and then 5 minus 4 times 2, so 5 minus 8 you will get negative 3, and 6 minus 4 times 3 you will get negative 6, and 24 minus 4 times 9 you will get negative 12. So here we have 0, negative 3, negative 6, and negative 12. Okay, alright, continue with row 3. So for row 3, this one is for row 2 is row 2 minus for row 1. Okay, alright, so for row 3 is row 3 minus 3 row 1. So you will have, it is, okay, for row 3 you will get this one. So it is 0, 5, negative 11, and negative 23. So the rest we have here 1, 2, 3, and 9. Okay, now let's continue. Next is check your ladder. We have here, okay, so this one should be leading one. Okay, continue next. Your R2 will be R2 divided by negative 3, and we will have 0, 1, negative 2, negative 12 divided by negative 3 is 4. Oh, this one would be positive 2. Okay, alright, and the rest we have 1, 2, 3, and 9, 0, negative 5, negative 11, and negative 23. Okay, next continue. For this one, okay, below the leading one must be 0. So we have here R3 is R3 plus, okay, plus 5 times R2, and you will get 0, negative 5 plus 5 is 0, negative 11 plus 10 is negative 1, and negative 23 plus 20 is negative 3. So this one you will get okay, next we have to check the ladder, and now you have the last leading one. So the last leading one will be your R3. Okay, you can multiply your R3 with negative 1, or you can also divide by negative 1. And just make sure that your target is you want to find that leading one. Okay, so I just use R3 divided by negative 1, and you will get the answer is 0, 0, 1 and 3. Okay, so okay, now let's check your ladder. Okay, you have the perfect ladder, and below your leading one are 0, so this is your REF. Okay, alright, so now since you have a leading one in all columns, so we say that all the columns here are pivot columns, right? So you have your leading variables. Your leading variables will be x1, x2 and x3. Please make sure you use the same variables as given in your questions, x1, x2 and x3. Okay, so for the first column, it represents your x1, second column is x2 and third column is your x3. Okay, how about the free variable? So since you don't have any non-pivot column, we say that there is non-free variables. Alright, now let's continue with our back substitution. Okay, for the back substitution, since the name is a back substitution, so it means you will substitute your matrix into the form of equation backward. Okay, so we will start with the last row. Okay, it will be backward. Starts with last row and then second row and then your first row. So for the row 3, okay, let's see here. We have the coefficient 1 for your x3 and we have constant 3. So in the equation, in the form of equation, it will be 1x3. So 1x3 you can just write as x3, okay, equals to, and the constant is 3. Okay, and then continue with row 2. So your row 2 here, we have coefficient 1 for x2 and 2 for x3 and the constant is 4. So we will write as x2 plus 2 x3 equals to 4. Okay, since your leading variable is x2, so you will write your x2 as the subject. So x2 will be 4 minus 2 x3, and don't forget we need to substitute x3 into your x2. So the answer will be 4 minus 2 times 3. So 4 minus 6 will be minus 2. Your x2 will be negative 2. And continue for row 1. We have here coefficient 1 for x1, coefficient 2 for x2, and coefficient 3 for x3. And lastly, we have constant 9. Okay, so now in equation, we will write as x1 plus 2x2 plus 3x3 equals to 9. And again, your leading variable is x1, so you will write your x1 as the subject. Write x1 as the subject, you will get x1 is 9 minus 2x2 minus 3x3. And don't forget, you need to substitute your x2 and x3 into your x1. And your x1 will be equals to 4. Okay, so now you will write in the form of matrix. So your answer will be x1, x2, x3. Okay, in the form of matrix, we will have here your x1 is 4, x2 is negative 2, and x3 is 3. So this is the final of your solution. So the solution for a system is you want to find the value for all the variables that you have in that system. Okay? Alright, thank you class.